We're the Stream Digestor team. I'm Rosie.
I'm Jovi.
I'm Tony.
I'm Madeline.
And we're going to talk to you about testing the feasibility of using strings in a trickling filter-esque system for wastewater treatment. So just to start things off, a little bit of background about wastewater treatment and why it's important. According to the UN, about 80% of wastewater globally is discharged back to the environment without treatment. And that is a problem because there's waste in that water that then humans are interacting with, whether it be through swimming, fishing, or agriculture, that cause obviously health concerns. And so if that water generally contains high levels of nutrients, so that can cause eutrophication and lead to algal blooms, which can be toxic. And also the high levels of organics in that water can lead to a depletion of dissolved oxygen, and then that water will no longer be able to support aquatic life. So this is a big issue, and we would like to do something about it. And so our team is aimed at creating some sort of system that could be used in a future aqua wastewater treatment plant that would align with the goals of a low-cost and electricity-free design. So last semester, we looked into the trickling filter technology. This is a picture of a traditional trickling filter with a distributor arm putting the wastewater over a system, the trickling media, which then a biofilm grows on that, and that's where the treatment happens. So microbes degrade the waste in the water. And from our work last semester, we identified some things that we'd like to keep from this old technology. So we want to maintain the rapid treatment that we see in these systems. And one thing we'd like to improve on is the surface area to volume ratio, which is where the surface area is where the treatment is actually happening. So we want to get as much treatment as possible in as little space as possible. And we also noticed wasted space in the system, which obviously is not what we want. So we want to minimize that wasted space. And what we concluded from that is that we should have strings as our trickling filter media.
So at symposiums, we discussed that the first set of strings we wanted to buy would be of material that was pretty much non-biodegradable, because the strings needed to pretty much withstand the harsh chemicals that they were going to be exposed to constantly, and it was apparent that any biodegradable material you used would not be able to withstand these conditions. So we bought 4 strings, 2 polymer-based and 2 metal alloy-based strings for our first set of experiments. And unfortunately, none of these worked. Unfortunately, we did not take into account that if it was non-biodegradable, it was probably going to be hydrophobic. And we did not take this into account, and each of the strings that we purchased were pretty much hydrophobic, and the surfaces of the string pretty much had no retention of water. But there was one big takeaway from these set of experiments, and that was that the string texture could be something of interest that we could take into account for these next set of strings that we were going to purchase. For example, the cable. It actually had like a texture, it had a spiral texture, and we noticed that when the water first initially hit that string, it would spiral down that spiral texture, but then fly off. So we thought that texture could be something we could take into consideration. For our second set of strings, we purchased 4 stainless steel chains and 4 foams. So we bought 4 chains, and we varied them in chains type and then also in size, because we wanted to see that if the texture would pretty much provide a path for the water to flow down. We wanted to see that if the texture would retain the water on the string media, and if so, which chain type would work best. And one thing to note is that all of the chains that we purchased were stainless steel, and then not only that, all of the chains that we purchased were unfinished, meaning that they had no finish, such as lubrication, to interfere with the water. And we also purchased 4 polymer-based foams, based on previous research of foams being used to treat UASB effluent. Foams pretty much can act as sponges, so we were pretty confident that the foams could retain all of the water that they were going to pretty much deal with. And we purchased foams that varied in characteristics. For example, one of them was super absorbent, one of them was super conformable, etc., to see which type of foam would work best in this trickling filter And one thing to note is that the gray foam is actually polyethylene, which is the far right foam, and then the first three are actually polyurethane based.
Alright, so with these new materials, we jumped in and started testing with a similar method as we did with our previous materials. If you've seen our symposium presentation, I'm just going to go through it quickly. We have kind of a basin at the top, and then the strings hang around that, and we pumped water into the basin, and then as the basin overflowed, the water has to go somewhere, so we hope that it will go down the strings, but we had issues with it obviously not doing that. So for these new materials, we tested with 3 different basins, 2 that had these, like the picture on the left, had straight sides, so they had different lengths. One of them was narrow and one of them was longer. And then we also tested with our winged basin, which has 2 quarters of PVC on the edges to give kind of more of a gradual slope. And so we just put our material on there and then tried various flow rates to see if just visually the water is flowing down in the way that we expected.
So these 2 videos are from our Chechen Experiments, and so the first one shows some of our observations that we noticed. So this shows, you can see the water basically spanning the gaps in the chain and then flowing down in droplets, which was something we'd hoped to see and did. And then the second video shows one of the issues we had with the chains is that, if you can see, there are only a few chains that water is flowing down. So it shows basically the inconsistencies with the water and basin setup. So that was one of the issues we had with the chains. So as we'd hoped, as you saw in the first video, the water did span the gaps in the chains, especially the jack chain and the bead chain. And so these were the best 2 chains. They showed the most potential. And you can see the other chains, the 2 sash chains, also had some potential, but the big sash chain didn't work really with our experimental setup. So if we were to use that, we'd have to have a different distribution method. But this, having a different distribution method is really consistent with all of the observations we observed with the chains. So one thing we noticed was that basically only about 50% of the strands on each side of the basin were getting wet. And so this would be an issue in an actual trickling filter, because a lot of chain strands are being unused, so that's a waste of space and not very efficient.
So here's a video we tested foams also. So in this video you can see that water droplets are being absorbed into the foam as they go down the length of the foam. And then at the bottom of the foam strands, there's water dripping off of all 4. And with the blue foam, the foam actually starts to get darker as the water infiltrates into the inside of the foam. And once again, you can see water dripping off the bottom of the strands. So the foam showed actually a lot of promise. The teal foam has potential, and we concluded this because it didn't work when it was not pre-wet, so we actually kind of had to dunk it in water, and then we laid it across the top of the dispenser, and the water would go through it and infiltrate it. The blue foam was very successful. On the other hand, this one actually had a cross-sectional area that was a little bit thinner than the teal foam, and this one worked when it wasn't pre-wet, but it worked better when we pre-wet all the strands. And the water was, it was going through the foam instead of on the outside. We also concluded that the white foam has potential. This one was a little bit harder to visualize in our testing just because of the color, but the strands got very heavy after we flowed the water through them, and there was water dripping out the bottom, so this led us to believe that the water was infiltrating it. Finally, the gray foam did not work out. The water formed droplets on this foam and it was not flowing down it really well. Some future directions of this team. We would like to keep working with the foams, and we want to figure out what cross-sectional area would be best to use for the foams in terms of the string. We also would like to quantify the rate at which the water is flowing down the different strings and also the volume that these strands are holding. In addition, we would like to address the pre-wetting problem and how that can be applicable to creating a string digester system and what would be the best way to implement this. And finally, we would like to start testing biofilm growth on the foam. If you have any questions, please reach out to us by email.
Also, if you're having any trouble seeing any of this, we apologize. We're lit by our iPhones right now, so if you couldn't see the videos, we invite you to look on the Google Drive and find our videos and watch them for yourselves. Thank you.
Thank you.